All right, folks, we are going to do 6.6 today, section 6.6, and that has to do with modeling real data, data that we take and try to model with sinusoidal functions. By sinusoidal functions, I mean either sine or cosine. So without further ado, we're going to go across to the notebook and we're going to talk about what we have here. So what we're looking at, and prepared it so you don't have to wait for me to copy all this stuff. We have a problem here. The table shows the average monthly temperatures for Ann Arbor, Michigan. It asks us to write a sinusoidal function that models the average monthly temperatures using t equals 1 to represent January. Temperatures are in degrees Fahrenheit. Now, what we say when we're talking about modeling data is we're taking data like this. This is monthly temperatures, the average monthly temperatures for 12 months in Ann Arbor. And what you'll see is they kind of follow that periodic nature. You think of seasons or our temperatures. In Michigan here in the winter, it's cold, then it gets warmer through to the summer where it peaks, and then it goes back to the cold again. So that periodic nature of just the repetitive cycle is something we can model with a sine or cosine function. That when they say sinusoidal functions, again, I want to reiterate, you can use sine or cosine. When we do this, what we do is we try to find a function that fits. Now, the first thing I'm going to look at, and I want to adjust slightly from what they tell you to use here, is this function right here. Now, you know, in ours, what we've been using is y equals plus or minus a sine, and I say sine, but this could be cosine, right? Of, in parentheses, b times theta plus or minus c and plus or minus d. C moving it left or right, plus or minus d moving it up or down. Now, there is one other thing we're going to change from that basic thing. When we're using data, we're often talking about time as our unit. So what you'll see is with this, we will use t often in here instead of theta. Time is our variable, so to speak, of the thing that's changing, our input. All right. So what do we do to do this? How do we find something that'll model this? Well, the first thing I do is I always look at my data and I look for the periodic nature. I try to see what's the one out of the key characteristics are lows and highs, right? It goes from either a low to a high to a low. That's what sine and cosine do eventually. So looking through here, starting at 30 degrees is pretty low. So I'm going to see if there's anything lower. Now that looks like it's my low. All right, now for a high, this is going up, up, up. Now back down. So I'm thinking that is the high, that is. So we know our low temperature is 30 degrees, high temperature is 84. So right off the bat, we see this happening where it's going low to high, and then look, it's coming back down to a kind of a secondary low, not quite as low as that, but another low. So what function? The first thing I always try to figure out is what function am I going to use that goes low, high, low? Well, let's look at our functions. If we look at the different type of functions we could have, and there's 4 different types. And let's see what the characteristics are of each of these. All right, so first we have y equals sine theta. And we know y equals sine theta starts at its middle, goes to its high, back to middle, down to the low. For our function here, this starts at its low. So in order for us to use a sine function, we would have to start here and basically translate this function that way. So we'd have to use a big C value. All right. So I'm probably not going to use sine theta for this. Secondly, we could use y equals negative sine theta. Y equals negative sine theta starts at the top, goes down to the bottom, up and back. So now again, if I want to start at my low, I would have to take this point and translate it and use a C value to do that. Probably not going to use the negative sign. All these are possible. You can use any of these. I try to find the best fit. So to keep going, if I go to y equals cosine theta, y equals cosine theta starts at a high, goes down to its low, and back up to its high, right? Now, almost. Starting high, we're starting low. So I'm probably not going to use this, but I could, if I wanted to, start here and translate, right? Start at the low and do a translated function. Now, finally, looking at y equals negative cosine theta, we have this. Starting at the low, it's going to go high, come back down to the low, and end, one period. This is perfect. Low, high, low, just like what we have here. So I'm going to use y equals negative cosine theta. All right. I've already made that decision. Now, so I know I'm using negative. I know I'm using cosine. Now I have to figure out what my A value is. Well, that's easy enough. A is our amplitude, right? So if I want to find my amplitude now, what am I going to do? If I want to find this, well, amplitude, remember in the very beginning, I told you there was a definition for amplitude that we said was the maximum value minus the minimum value divided by 2. Well, we have these values. Max value is 84 minus the minimum value of 30. We divide that by 2. That's 114 divided by 2 looks like, what, 57? Yeah, 57. So 57 is I'm sorry, 54 divided by 2 is 27. Sorry. Getting ahead of myself. 54 divided by 2 is 27. So our amplitude is 27. So now, what have we done? Already at this point, we can write part of our equation. We could start out and say, what are we going to write? We are going to write it as, let's just do it here. Y equals negative 27 cosine. Now we need a B value, right? We need this thing. So let's try to find a B value. Using this, all right, B value, what is that? That's our period. So how do we look at this period? Well, they told us that we're using this range of values. Well, if January is 1, then we got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12 seasons. So, or 12 months. Those 12 months, that's our period, 12 months, right? Because these are average monthly temperatures. So our period is 12 now. What was our original period? Remember B, we said before that B was going to be equal to the original period, which is 2 pi, divided by our new period. Our new period is 12. So we get pi over 6 for our B value. We can put pi over 6 here. Now, again, we're using time, so I'm going to put T here. Now, they said January was 1. So technically, using this negative cosine graph, if we were at 1, we'd want to be here. So we have to move this to the right 1, right? To start at that bottom being 1. So that being the case, I'm going to do minus 1. That moves it right 1. And I've taken care of, honestly, B and C there very quickly. Right? This right here told us C equals negative 1, right? Moving right 1. Now, finally, going back here, we need our D value. Well, what is the D value? D value is your axes, right? So we need to find what D is. In order to do that, we got to think of, all right, this is our axes, or you can think of it as your vertical shift. We've called it both. So how do I find that? Well, that is the middle value. So isn't that the average of the max and the min? It has to be. So we're going to use 84 plus 30 divided by 2. That gives us the average of our high and our low, high plus low divided by 2. And that's 114, not what I said up there. This is 114, which divided by 2 is 57. So this number is 57. So, and it's a positive 57, so we put plus 57. And we have our function. So pretty quickly, just finding a few values and understanding the nature of the graph, we can decide pretty quickly what the function is to model this. Now, if they ask you for, say, July, or well, we already know July's. Let's say if we see how well this models our graph and we want May's temperature. Well, if January is 1, then 2, 3, 4, 5, I would plug in T equals 5 and figure out this value. It's that simple. All right. So let's do another one. I want you to get some experience with this. All right. So now we got another one. We've got the buoy problem. This is one that's very popular. A buoy bobbing up and down in the water as waves move past it, moves from its highest point to its lowest point, back to its highest point. So they just told us high, low, high. What kind of graph is that? Right now, before I go anywhere else, what have they told me? They've told me I'm using y equals cosine theta, haven't they? If it's going high, low, high, isn't that a cosine graph? All right. And it does this every 10 seconds. What did they tell us there? If it goes here to here to here every 10 seconds, they told us the period is 10 seconds. The distance between the highest and lowest point is 3 feet. So this distance from high to low is 3 feet. That's telling us a couple things. All right, so let's see what we can do with this. Again, using our idea, whoops, I made a random mark there. Y equals plus or minus A times sine B T plus or minus C plus or minus D. So let's go one by one. First off, we know already that we've got y equals, and it's going to be a positive cosine. So I can put cosine here. Now I got to find my A value. Well, we know that the difference between the highest and the lowest, the max and the min, is 3 feet. So doesn't that make our amplitude half of that, 1.5? So we would do a positive. I keep randomly making marks there, sorry. 1.5 cosine. What did it tell us about our period? They told us period is 10 seconds. I don't even need to rewrite that. It's right there. So we got that. So we can find our B value. B value, normal period of cosine is 2 pi. We're using 10 seconds. That means pi over 5 is our B value. So I put pi over 5 here. And I have t plus or minus. Now, if we say that it starts at its highest point, do we need to have any C value? If it's starting immediately at its highest point at 0 seconds, then C is 0. And we can just eliminate this part and say pi over 5t. And we don't need a C because we're just going to start it right at the beginning. Timing 0 seconds, top of the wave. All right, the buoy's at the top. Now, the last thing is, where is our middle? Well, if we say that the high point is 3 feet, then we would have to say plus 1.5. But if we just say this is a wave that from its what we call equilibrium point, its middle point is at 0 height, and then the wave goes up, brings it up above what's normal height, then drops down below, which is really how waves work, right? We don't even need a D value because we'll just leave 0 at height 0 would be its midpoint. So we can leave it just like this and have this as our function. That would model a wave going from its high point down to its low point, back to its high point over a 10-second period. All right. One more example I think we've got. Let's see what we have here. All right. An average seated adult breathes in and out every 4 seconds. What did they just tell us? Well, breathing in and out sounds like a cycle every 4 seconds. I'm going to guess right now that that's my period, is 4 seconds in to out. The average minimum amount of air in the lungs is 0.08 liters, right? The average maximum amount of air in the lungs is 0.82 liters. Suppose the lungs have a minimum amount of air at t equals 0. So this is t equals 0. They're at their minimum, where t is the time in seconds. Write a function that models the amount of air in the lungs. All right, now think about that. If we're going to write this function, what would be the type of function we're going to use? I'll give you a second to think about that. All right, so they told us that the minimum amount is at t equals 0. So where's the minimum t equals 0? That would be y equals negative cosine theta, right? This right here tells me y equals negative cosine theta is what I'm using. So we're going to use that. Now, they want us to graph the function. In order to graph the function, we have to write it. Actually, they ask us to write it. All right, so let's write this. So what are we going to do? We've got y equals, we know it's negative. We got to find our a value. Well, how do we find a? Our amplitude, I'll write it out. Amplitude is going to be what? It's going to be the maximum, 0.82, minus the minimum, 0.08 divided by 2. And what's that going to be? 0.74 divided by 2. I think that's going to be 0.37, but I'm going to double check this. Minus 0.08 is 0.74 times 0.05, 0.37, 0.037, sorry. No, 0.37. All right, 0.37 is that. So now we say 0.37. We know it's cosine. We need our b value. Well, they told us period is that. So b is going to be 2 pi divided by 4. So that's pi over 2. Right? So we have pi over 2. Now, before I put that there, think about if it says it's starting at its minimum at t equals 0, I'm not going to need a shift left or right. I'm not going to need a c value. So this is, again, going to be this. And then I have to figure out how high up it is. Well, we have to find the midpoint here, right? So midpoint, or axes, is going to be when we take 0.08 and add 0.82 and divide that by 2. So what's that? 0.9 divided by 2 is 0.45. So we do plus 0.45. And that gives us our graph. I should say our function. Now I'd ask you to graph this. How would I graph this? Well, think about it. We can graph this pretty quickly. Let me get an axis quickly. I might want to move this up a little bit. All right. So what am I going to need? I know I need to do, let's see. I know I'm going to 0.45. So let's go to 0.45. And let's make our axes. I know I'm going to go down 0.37 for a minimum. So 0.08, right? That told us that. 0.08 is our minimum. And 0.82 is our maximum. We know it has a period now of pi over 2, right? So what we can do for, well, I should say we have a b value of pi over 2. We have a period of 4 seconds, sorry. So we have a period of 4 seconds. So we go out to 4, take half of it, 2. That's 1. These are in seconds, right? Because we're input is time. And 3. And we have everything we need. Now we can go to graphing. Let's graph this thing with a little bit bolder line. It's a negative cosine, so it's starting at its minimum, going to its midpoint, going to its max, back to the middle, and down to the minimum. So our graph of these breaths being taken would do this, and it would go on. And that would graph the function. That's all we need in terms of axes labeled, right? This, I guess you could call this liters. That would probably be a good idea. And, excuse me, if they ask you to determine the amount at t equals 5.5, all we do is plug that in. So what am I going to do? First, I'm going to take and I am going to share this screen with you. Let's do this real quickly. I want to share with you this screen so you can see my graph. All right, I'm going to graph this first, doing y equals clear. Let's do, we're going to do y equals negative 0.37 cosine of pi over 2. I'm going to put that in parentheses. Second pi divided by 2. And then that's times t. That'll be our x in this case. Close those parentheses. And then plus 0.45. And window. My window, we just said what we need. I'm going to go, x min and max is going to go from 0 to, well, they want us to find 5.5. So I'm going to go a little bit farther than that. The X is going to be our time in this case. So I'm going to go out to, let's say, twice our period. Let's go out to 8. Let's see, 2 full breaths. Breaths. It's hard for me to say that. All right, so scale. Let's do by ones. So let's enter by 1. And Y min and max. Well, we said we're starting, we don't go below 0, and we don't go above 1. So let's just go 0 to 1. And we'll scale it. Let's do the scale to be, let's just leave it at 0.5. All right, so let's do it. Let's be tricky and do 0.45 so we can see our midline. All right, so let's graph that. Sorry about that. Let's see. I think we're ready. Let's graph it. All right. So if we wanted to now, we could just do second calc, and the value we want is at 5.5. So 5.5 is our input, and it tells us at t equals 5.5, our y value is, oh, I lost that, sorry, is 0.711. So 0.71, we'll say, liters. Y equals 0.71 liters. And we'd be done. All right, so that's what we're going to be doing, guys. They're going to give you sets of data. We're going to give you that stuff. You need to find, remember, max, min, what kind of function are we going to use to model it, all that kind of stuff. All right, so give these a shot, and we'll answer your questions tomorrow. Have a wonderful day.